Good morning, doctor. My name is Kampushan and my metric number is 230-873. Today I'm going to talk about the assignment 1, which is understanding fluid property and their impact on engineering system. In this presentation, I'm going to introduce three fluid properties, analyzing their application in engineering, as well as identifying and resolve a conflicting engineering issue. The first fluid property is viscosity. Viscosity is the measure of a fluid resistance to flow. The SI unit for it is Newton second per square meter or pascal second. High viscosity fluid resists motion, making it harder to flow, while low viscosity fluid makes the fluid easy to flow. Next is surface tension. Surface tension is property of the surface of a liquid that allows it to resist an external force due to the cohesive nature of its molecule. The SI unit for it is Newton per meter. High surface tension fluid means that it has stronger cohesive forces between molecules at the surface of a liquid, while low surface tension fluid means that it has weaker intermolecular forces between the fluid molecules. Lastly will be density. Density is mass per unit volume. The SI unit for it is kilogram per meter cube. High density fluid means that it has larger mass for a given volume, while lower density is it has smaller amount of mass for a given volume. Now I'm going to talk about the pumping and piping system. So these three fluid properties are going to affect our system, so I'm going to talk about it. So first is viscosity. High viscosity fluid has higher energy consumption, so more energy is needed to maintain the flow rate, while low viscosity fluid has lower resistance for narrow pipes, however it can cause leakage. Secondly is surface tension. High surface tension fluid resists breaking up into droplets, but it would influence the severity of cavitation causing pipe damage. Whereas low surface tension fluid improves pump pumping efficiency and easy to optimize. Lastly is density. High density fluid exert greater hydrostatic pressure, so more energy is required to move the liquid. But low density fluid exert less force on pipes, therefore less energy is required to deliver the fluid while maintaining the flow rate. The engineering issue that I chose is multi-phase flow transport in oil and gas pipelines. The reason that I chose this issue is because of the occurrence of unwanted flow regimes, for example, sludge flow or pseudo-sludge flow. The consequences of these two unwanted flow regimes are pressure surge, vibrations, pipeline fatigue, and damage to surface equipment. Now I'm going to explain how these three fluid properties will affect oil and gas pipelines. So first is viscosity. Low viscosity fluid flows easily, but it increases likelihood of turbulent flow, while high viscosity fluid means that it is difficult to flow. However, it suppresses wave formation and encourages structural sludge flow at high velocity. Secondly, surface tension also affects oil and gas pipelines. Low surface tension fluid form ripple waves on the gas-liquid interface, but it reduces pseudo-sludge and transition flow regimes, while high surface tension fluid promotes pseudo-sludge flow by delaying the breakup of liquid sludge at high velocity. Lastly will be density. Low density fluid has weaker hydrostatic force, and this increases the instability at phase boundaries, while high-density fluids stabilize annular flow at high velocity, but it increases the risk of sludge formation if not properly managed. So now I'm going to talk about the solutions to mitigate this problem. So first, we can install flow conditioning devices. For example, flow stabilizer that controls flow velocity and fluid distribution. Secondly, we can modify the fluid property. For example, we can use surface tense to reduce surface tension and stabilize flow. Lastly, we can also optimize the system design by using flow regime maps to model and predict behavior of fluid under different conditions. This will be the end of my presentation. Thank you for listening.